This is Fundamental Problem 21 from Chapter 15. Initially, the 5-kilogram block is moving with a constant speed of 2 meters per second around the circular path centered at O on the smooth horizontal plane. If a constant tangential force is applied to the block, determine its speed when t is equal to 3 seconds, and the constant tangential force has a magnitude of 5 newtons. So, this is what they give us in the problem. We have the mass, we have the velocity, we have the constant tangential force. It's a smooth plane, so there's no force of friction. Here's our equation for angular momentum and our equation for the moment. That's equation 15-13 for the angular momentum, and then our equation for the moment here. And then we have our relation for the angular momentum and the moment, which is equation 15-18. So I have those here. Can take the equation for the moment and put it in here. And then we can simply use this equation to find the final velocity. Now, when you're doing the moment, it's supposed to be the sum of all the moments acting on object A. In this case, there's no force of friction, and if there was a force in this direction, that would be parallel to your vector here, so the cross product would give you 0 for that. So we have only one force, which is going to give you a non-zero moment. And let's go ahead and find the initial angular momentum and the final angular momentum. So we have the initial angular momentum. It's the vector r, which is going to point A from the origin. So here's our vector. And whatever direction that vector is pointing in, since it's going from the origin to the location of object A, it's going to be perpendicular to the velocity. So because it's perpendicular, the magnitude of the cross product is just going to be the length of this vector, which is 1.5, times the mass, which is 5, times the initial velocity, which is 2. And that vector, if we do the cross product using the right hand rule, it's going this way for the vector r, and this way for the velocity vector, so that's in the positive k hat direction. And then I can also write an expression for the final angular momentum. With the final point, which is 3 seconds after, this vector is going to be pointing in a different direction, but it's still going to be perpendicular to the velocity. So, and it's still going to be pointing upward, so in the k hat direction. So we have the length of the vector r, which is still 1.5. The mass is still 5. The velocity is now, okay, we're calling it v2. So the velocity is v2, and this is in the k hat direction. Then I have for the moment my vector here crossed with the force. The force is also perpendicular to my vector r, and the force and the velocity are in the same direction. So for the cross product, you also get k hat. So the magnitude of your vector is 1.5, and the force is 5. Okay, so we're going to put that in here now. So I have 5 times 2 is 10 times 1.5. That gives me 15, plus 1.5 times 5 here, then integrated. Now they told me that the force was constant. The length of the vector r is not changing either, so both of these can come outside the integral. So let's just do this. Going from t1 to t2, t1 is 0, t2 is 3, and this is equal to the final angular momentum, which is 1.5 times 5. And well, if I left this as 1.5 times 10, let's put it back like this, 1.5 times 10. Then I can cancel this 1.5 out. So I have 10 plus 5 times this integral here going from 0 to 3. That gives me 3, is equal to 5. I forgot the V2 here. And this was pointing in the k-hat direction. Okay, so those are all going in the k-hat direction. This is just the magnitude of the velocity that I have here. So what am I looking for? Find V2. Is that supposed to be the direction or just the speed? Determine its speed. So we really want the magnitude of this, which if you want to be there, you can leave it like that. Okay, so we're looking for the speed. Okay, so now I can just solve this. And I could divide everything by 5 too. So this would be 2 plus 3 is equal to the magnitude of the velocity. So the magnitude of the velocity is 5. And that concludes fundamental problem 21. So for this problem, we were basically just plugging in to equation 15-18, and it was easy because when we did the cross products, everything was either parallel or perpendicular. So that concludes fundamental problem 21.